Today we are going to see the topic wall shear stress. Hi friends, my name is Aditya Ingale. First we will see what is the shear stress. First we will see what is the stress. In mechanics, stress refers to the internal force or pressure experienced by the material when it is subjected to external loads or forces. It is a measure of the intensity of the force acting within a material and is typically expressed as force per unit area. At the formula says stress is equal to force divided by cross sectional area is denoted F divided by A. Move forward. Now will we see what is the shear stress. Shear stress refers to the force per unit area that acts parallel to the surface of an object causing to deform or undergo a shearing movement. It is a measure of the intensity of the material, the internal force within a material when subjected to a shear loading. Now we will see what is a wall shear stress. Wall shear stress refers to the force per unit area extended by a fluid parallel to a solid boundary such as a wall. It is measure of the fabrical drag extended by the fluid as it follows along the surface. The shear stress axis from the fluid's velocity gradient near the wall where the fluid in direct contact with a wall has zero velocity while the fluid further from the wall has higher velocity. When the fluid flows over the solid surface, the fluid particles in a contact with the surface slow down due to the no slip conditions, which it states that the fluid velocity at the wall is zero. The wall shear stress is a measure of the force that develops due to this velocity gradient. Look this figure and understand the velocity is moving forward in the figure. The formula for the calculating the wall shear stress is tau W is equal to mu dV by dr. In aerodynamics, wall shear stress refers to the frictional force per unit area that acts parallel to the surface of an object or boundary layer in contact with a fluid, typically air. It plays a circular role in various aspects of aerodynamics of their analysis and designs. Here are some key points of application of wall shear stress in aerodynamics. First, we will see the boundary layer analysis. The wall shear stress is an essential parameter in studying and analyzing boundary layers, which are thin layers of fluid adjacent to a solid surface. By examining the distribution of wall shear stress, engineers can understand the behavior of the boundary layers, such as its thickness, separation points, and transmissions from laminar and turbulent flow. This information vital for designing efficient aerofoils, wings, and other aerodynamic surfaces. Secondly, drag perfection. Drag is a resistance expended by an object moving through a fluid such as air. Wall shear stress is directly related to the drag force acting on a surface. By accurately estimating the distribution of wall shear stress along the surface of an aircraft or vehicle, engineers can predict the analysis and the drag force acting on different components. This information helps in optimize the design to reduce drag and improve
Overall efficiency.
One is surface friction. Wall shear stress is measure of the surface friction extended by object. This wall shear stress indicates a higher level of friction which can be stable in certain aerodynamics applications. Engineers derive to minimize wall shear stress to reduce the energy losses caused by friction and improve the performance of the aircraft, vehicles and other aerodynamic systems. We will see the wall shear stress and moment thickness. Therefore, the drag force can be related to the momentum thickness as d is equal to u v infinity square theta for a unit wide boundary layer, and the relation is wide for laminar or turbulent flows. It is known as that d is equal to integration plate tau w dx. The stress tau w can be directly related to the gradient of the momentum thickness along the streamwise direction. Recall that from laminar flow, the wall shear stress is defined as tau w is equal to mu du by dy. Thank you for watching.